MTD CNC, bringing you the latest engineering news, reviews, events and special offers via video media.
We've had an exclusive invitation to the Star GB Discovery event. Now this event is slightly different from most open houses. We're here to learn about what you can actually achieve with slide-in head lathes. There's lots of different applications on show. We're going to meet with Alec Warner, who's going to talk to us not only about the hardware, the machines, but also the software as well, and how Star GB can make programming and operating of sliding head lathes very easy. So let's go inside and meet with Alec. So Alec, this is the first application we're going to look at here at the Discovery event. Tell me why you've chosen to manufacture a part like this.
This part replicates a medical burr that we was asked to look at by a customer a few months ago. So we thought this was our ideal opportunity to show a similar part at our open house.
And what stands out to me is obviously the diameter that you're machining to and the length of the part as well.
Exactly, this is a less than 1 millimeter diameter and it's over a 40 mil span. So it's quite a difficult feature to produce. But obviously the twin platen capability on this machine gives us that opportunity.
So if I was to take this part off you here, Alec, tell me, how do you go about turning it?
First of all, the head is roughed, okay, and then we bring two tools in, two turning tools, DCMT style tools, almost down to diameter on one side. Finish tool is on diameter on the other side, and as the material passes through the guide bush, these two tools stabilise the component as it passes through, turning simultaneously on both heads.
And how does that affect the concentricity or the accuracy?
We're able to turn a very straight diameter, and it's a very stable diameter. Obviously the forces on one side of the platen are offset by the forces on the other side of the platen.
Okay, so it gives you a more stable but equally as accurate turning operation.
Absolutely.
So looking at the part here, Alec, you've got a hexagon machined in there and also some engraving. How do you do that?
We've got a special shaving macro that we've developed for our machine tools, which basically makes very fine cuts in rapid to generate the hexagon in the 6 corners of the broach. On the very tough materials, we can't wobble broach, we can't punch broach. We have to shave the material off in very fine steps.
And how would a customer go about setting this on their machine?
The macro itself we give freely out to any customer that wants to use it. It was developed for fastener companies in the Midlands, but we've given it to many customers that are machining similar features on their components. So it's good for hexagons, it's good for keyways, those sorts of features we all do with this shaving cycle.
So that's the broaching, but what about the engraving?
Again, the engraving was developed for fastener companies, marking the size of the fastener on the face of or on the head of the fastener bolt. But we've basically expanded this cycle so we can now use it on the cylinder of components, on the face of components, on the side of components. But it's a macro that we send out to any customer that wants to utilise it, really. So.
And does that apply across all the machines and not just this one?
It does apply to all the machines. We've developed it to suit the whole range of models that we have in our portfolio.
Okay, so talking about other machines, this has been a great start. We're now going to go and look at something that's a complete contrast to this component over the other side of the showroom. Alec, we've got here a shaft. You're machining this on this machine?
Absolutely. This has been done on an SR32J. We're doing this and supporting it in the sub-spindle at the same time. So it's very much a staged process, machining the shaft all the way down. So we'll basically start at the beginning, do the center drilling, the turning, the cross drilling. We'll then turn this section down so far. At that time, the sub-spindle will come over and support on this diameter, and then we'll turn the next section of the shaft, and vice versa, all the way down, until we've got the component this end, we part it off, we take it away, and we process the rest of the component in the sub-spindle.
I can see why you've chosen to show this particular application, because as I look at this shaft, I wouldn't associate this with a sliding head lathe, so it's very different.
We've got lots of customers that are doing longer parts than this, but we felt, 1 metre part was a nice round number and maybe not as complex as this particular component, but it does show the versatility on the 32J. And obviously you can see, it's a very nice finish. We're turning very close to the guide bush. So it's a very sort of traditional sliding head component, but on a much, much bigger scale.
I was going to say, that surface finish looks ground, is it?
It's not ground, no, but it is very, very good. So, the component has come off and we're very, very satisfied with it.
Okay, we're going to move on to the SV38R now. From my experience, Alec, this particular component, I would look at doing this on a twin turret, twin spindle turning centre, but you're doing it on a sliding head lathe.
We are. This is being done on the SV38R. This particular machine has the ability to machine in what we call non-guide bush mode. So it's a configurable machine tool where we can offer guide bush operation or without guide bush operation. That allows us to turn this component in a similar fashion to fixed head machine tools. So we can clamp it once, we can use the platen and the turret to simultaneously turn this diameter down, but it gives us the opportunity to go up to 42mm diameter.
I was going to say, because you've got 38 here, but you're actually machining a 42mm diameter.
It is, it's from 42mm stock, and we can only do that in non-guide bush mode.
And this machine also has a turret on it rather than platens, or it's got platens and a turret.
On head one, we've got platen and we've got turret, so we can mount an awful lot of tools on the turret. The turret gives us 10 stations, and we can mount 3 tools per station in a lot of cases.
So why have you chosen to actually manufacture a part like this at the event?
There's a lot of, like you say, twin turret, twin spindle machines in the 42mm class, so we needed to show that our slider has that capability, and with the turret, with the B-axis, gives us a very versatile machine tool to do such parts.
Alec, thank you very much for your time today. We've learnt a lot.
You're welcome.
For more videos, products and news, go to mtdcnc.com or follow MTD Online on Twitter.